everyone, my name is CJ Abraham. I'm a product manager for Fusion. I work with the user interface for CAM, the manufacturing workspace. So I'm going to talk about a visit that I had over at Renishaw in Toronto, where they have their additive manufacturing machines. So they use direct energy deposition to do 3D printing with powderized metals. What you see here is a part that was printed using 316 stainless steel. And we did some post-machining on the Matsura MX550 5-axis machine that they have at the facility. Okay, so we went through some design for manufacturing processes where we took the model and we determined that there were some areas that needed to be fixed in order to be printable. 3D printing with plastics is very, very forgiving. You can get away with a lot, especially if you're using support materials that are different than the model material. You can usually dissolve those away, which is not the case with powderized metal. In general, you need to avoid high draft angle, so anything over 45 degrees won't work. You also need to avoid thin structures so that the heat has areas to dissipate through, so that you don't burn your print. On this part, we actually did have a burn because we had an area, it's kind of at the bottom of the grid board there, where we didn't really realize there was a high draft, so you can see a little portion missing out of that. But it was a learning experience, and we learned a lot from making this part. It was a lot of fun. So this is what the print bed looks like as it's printing. You can see, I can see it on my screen, I don't know if you can see it up here, but there's lines that are going down the powder. This was from the area that burned in the print, and it damaged the bar going across the top there. That when powder is laid, that bar goes across the top, and it makes a nice thin layer of powder, right? So what we have there is obviously the damage to the bar won't lay a perfectly thin layer of powder, and that goes all the way up the print. So making these considerations is really important. And there's another picture of that, a little bit close up. And the process is very analogous to welding, right? We're welding the material layer by layer. Okay. The environment is an oxygen-free argon environment, so they have to pump out all the oxygen from the work area and then pump argon back in. Okay, that's what the door looks like. And this is the print when it's finished. So it starts with one layer and the print bed moves down as each layer is added, and it singes and welds the top layer. And you basically have a nice little archaeology experiment at the end where you have to move all the powder away. Okay. And that's what it looks like when it comes off of the bed. Right, so we've moved all the powder away, that's what we're left with. And you can see that the diamond shape and the big bore there, that's the designs that we've added for manufacturing. I'll talk a little bit more about that in a second. Okay, a couple more pictures there with some light. That's the area that burned. Okay, so the heat had nowhere to go because that layer was very, very thin and it started potato chipping, right? And that potato chipping is what damaged that bar, and it just compounded. So any areas that were above that burn also become affected. Okay, you can see the lines on the bar there. Okay, having a little fun there. And this is what it looks like when we're getting those pieces off of the print plate. So we just saw that off. Some places will use a wire EDM to get that off, but it's a slow process. This is just quick and it works. Okay, and then for holding it in the machine, we 3D printed soft jaws. So we went through a design process, making it so that we could hold it very effectively. Right, these it's not just straight walls either. It's contoured around the part, and it holds it very securely, surprisingly securely. The only thing we had to do after that was probe the part, and I don't believe I have a picture of that actually. And what it does is Renishaw has software that will take the inspection. We take a lot of points across the part, and it will rotate the stock into the orientation of best fit for the model. Okay, so if there's discrepancies in the model in one area, and maybe not so much in one area, it will move the stock around the part so that the part is evenly spaced inside of the stock that's available. Okay, so that's me setting up the machine to do this thing. Okay, And unfortunately, I don't have much video available of the part. This is kind of impromptu for me to do this presentation. But we spent time in Fusion programming the part and machined it. And it was a great process overall. We did all of this in Fusion. So Autodesk owns NetFab, which is a great 3D printing utility. And we've integrated that technology into Fusion. So this is a 100% Fusion workflow where we do the design, we make modifications to the design for 3D printing, we do the toolpathing for the additive machine inside of Fusion, we send that data out to the printer and it prints, then we do the soft jaw design in Fusion, okay, so those soft jaws with the vise and everything, that was all modeled up in Fusion, and then we did the toolpathing in Fusion and posted code to the machine. So 100% Fusion workflow. And that's what we're going towards for push-button manufacturing, right? The idea here is that we can make design changes, like take that big bore in the center or either the ones on the side there, we can move the positions or we can change the size, and that should be able to update everything downstream about my manufacturing process, right? So it should update the diamond shape that I did in the center bore for printing. It'll modify the size of the bore for that. The soft jaws will be modified, the program will be modified for the machine. All of that is updated automatically downstream. Any questions about the process? Anything like that? No? How much more time do I have? Only 5 minutes? Okay. How long does it take to print? So we did 3 parts, right? That took 18 hours to print. So it's quite a long process, and I had to do it overnight. The workshop was 3 days, and so I'm not a professional in 3D printing, but the guys at Renishaw are. So when we did this exercise, they had to take some design, they had to take the wheel for some of the design aspects, right? So that it would be a successful print. Even though it did burn, I'm glad that it did, because this was a better learning experience than if it had gone perfectly, right? The idea here is that for anyone that's machined parts, you can't have internal sharp corners, right? You can't. Same thing here, you can't have drafts over 45 degrees or else you're going to burn without supports, right? So these are kind of the requirements for design for 3D printed parts that sometimes software can't tell you, right? The machining side probably took only 20 minutes, right? It took a while to set up the machine because that's what it takes for machines, but the toolpaths only took a couple of minutes. Any other questions? That was a great question. I'm sorry, I can't hear you, sir. Material? It's 316 stainless steel. Yeah, the material comes in little jugs, plastic jugs, and you know it's powderized, but it's still quite dense, and they're very, very heavy. They operate in clean room. So let me try and find a picture. So I'm gonna not share my screen for a second here, so I don't show anything accidentally. And I'm looking for a picture of the clean room. Here we go. Oh, it's working now? Okay, great, yeah. That's the clean room and that's the machine. Whoops. There we go. So the powderized material, if it becomes airborne, is extremely dangerous. You don't want to breathe it. The particles are small enough to get through your skin, so you don't want that going through your bloodstream. But it's really cool to work with, right? You make neat parts with it. This machine in particular is kind of one of their older models, one of the original ones that does not recycle the powder, and so they had to manually load the powder. Any leftover powder has to be sifted and recycled and then put through the machine again. Newer machines do self-recycle the material, so they can be run continuously. This machine, if you had the rather large print, maybe over 24 hours, someone would have to be there to monitor the machine and be ready to change the recycled material canister or the leftover material canister. For those newer machines, that's not required. It can run unattended. Thank you very much.